Hello everyone, welcome back to my channel. Today I'd like to talk about the biggest paradigm shift in shipping industry, a transformation that gained momentum through the historic Paris Agreement signed during COP21 in Paris 2015. Through this landmark agreement, world leaders committed to working together towards achieving net zero carbon emission by 2050. While the interim targets have evolved over time, one thing remains very clear: decarbonization is essential for protecting our planet for future generations. The shipping industry, which accounts for nearly 3% of global carbon emission, is undergoing a significant transformation by adopting cleaner and more sustainable technologies. This video was recorded during a technical seminar at Ganpati University, organized in collaboration with Institute of Marine Engineers India. It was a privilege to share my perspective on latest green technology, their practical implementation at sea, and the challenges, opportunities that they present for the future of maritime shipping. First up is solar power and its utilization at sea.
Present day PV panels efficiency is very low. It is somewhere around 22%. Maximum it can go up to 23%. So this efficiency is very low. Secondly, solar power is not available on demand. Okay, so that means I do not have power available round the clock. I do not have power available when I need it the most. So this is a drawback. But still I can use solar energy as a supplement to my auxiliary power. That means if I have some solar panels on my ship, that will improve my CII ratings. My carbon emissions will reduce.
Next, I want to talk about wind power at sea. We do not convert wind energy to electrical energy, we use it directly to generate forward thrust at sea.
So we have been using wind power for 5,000 years now, especially Indians. The name sailor comes from sails. Okay, so we have been using wind power for quite a long time. Now we are returning back to it. So basically returning back to the basics. How we can use wind power is we have something called WAPS, Wind Assisted Propulsion Systems. There are four major wind assisted propulsion systems. One is rotary sails. You can see the diagram on top. This is a rotary sails. Then you can have a kite. You can have a soft sail. Soft sail is basically use of fabric or something that can be folded. Then you have hard sails, something that is rigid, it cannot be folded.
Any discussion on green technology is incomplete without hydrogen. So I am discussing the use of hydrogen as fuel for ships.
We can start using hydrogen. But how that hydrogen is produced, that is very, very important. You can produce it by coal gasification. You can produce it by using steam and methane. But these particular type of hydrogens are not considered very environment friendly because you have emitted lot of CO2 just during production process. The best kind of hydrogen that is available is green hydrogen, hydrogen produced by using renewable power. Okay, so we want to use green hydrogen. Let's see. Yes, it is a true zero emission fuel. If you want to use green hydrogen on your ship, you can achieve true zero emission. There are two ways of burning hydrogen. You can use a hydrogen fuel cell or you can use a hydrogen combustion engine on your ship. Okay, it has a very high, fantastic calorific value, almost 3 times of diesel itself. Then why isn't the world rushing towards hydrogen? If these details are true, ship owners should be lining up.
Next, I want to talk about something very unique, that is air hull lubrication system, When I first studied this system, even I wasn't sure whether if the system will work or not. But then I read more, I got into experimental data and found that the system was legitimate.
Then last, one of the most talk about method is air hull lubrication. How does this work? We last year BTech 9 students actually made an model working on air hull lubrication. So in under air hull lubrication, what we are doing is we are pushing compressed air below the keel plate. We are pushing compressed air below the keel plate so that the contact surface of the hull and the water breaks. We want minimum contact between hull and the water. This will result in lot of drag reduction because viscosity, if you remember, is basically friction between the layers of fluid. If you change the fluid, the friction will reduce drastically. For example, I can move my hand in air very easily, but if I would have been in water, it would take a lot of energy. Okay, so all this work has been going on.
Thank you for listening to me. If you have come so far in this video and you find this kind of content interesting, then please subscribe to my channel and stay tuned. Until next time, bye bye. Thank you.